Okay, this is our first video for the control systems unit. In this unit, I want you to understand the different ports on a VEX Cortex microcontroller. That's our microcomputer. I want you to be able to write a computer program to move a VEX robot, and I want you to be able to use void statements to navigate a robot through a maze. So let's get started with a microcomputer. This is the VEX Cortex. It's a microcontroller. And when we take a look at it, we see there's a bunch of different ports here. On the left side here, we're looking at this middle picture, this side is for analog. Analog sensors. Analog means it can sweep through a bunch of values. So think about a clock, how a hand on a clock can sweep through a bunch of different numbers. And analog can sweep through a bunch of different values. Still on the left, right here, here we have our digital. So for digital sensors, digital means it's either on or off. So think about a switch, like a bumper switch or something like that. So, if something's pressed or it's not pressed, that would be a digital signal. On the right side here is where we have our motor ports. You will find 10. If I look at the front of the Cortex, right here you just see a little tiny plug. That's for our 9-volt backup. This port right here is for our main 7.2 volt robot battery. You will also see the on-off switch, and really that's all we really need for this robot. So this microcontroller, just to give you some information about it, features an STM microelectronics ARM Cortex M3 user processor. This unit is responsible for translating the programming. So you're going to write out some programming. You're going to write some code. The Cortex here then will translate it, and then read the instructions, and then basically process commands, execute responses, things like that. So this, the array, the ports and everything that allows us to use. Basically, we get 10 motor ports, and of those 10, 8 of them are a 3-wire, and then 2 of them are a 2-wire port. So what that means, our DC motors all have 2-wire connectors, so you have to use something called a Microcontroller 29 that converts the 2-wire to 3-wire. We got one I2C smart sensor port, 2 UART fast serial ports, 8 high resolution analog ports, and then 12 fast digital ports. The battery, again, is a 7.2 volt robot battery with a 9 volt backup. Okay, so let's get into the actual coding of this. How do we write a code? Well, basically we need to break this down into different behaviors. Now, a behavior is anything your robot needs to do, like turning a single motor on or turning a single motor off. Moving forward, that's a behavior. Staying in a line is a behavior. Navigating through a maze might be a behavior. So we have 3 main types of behaviors: basic, simple, and complex. So here we have a little bit of code. All of your codes will start off with the main task. And then all of your main tasks will fall between these, I guess, squiggly brackets, if you want to call them that. So everything you write stays within those. And then we have some different words that we can type in. So this first one, B, motor reflected, port 2 equals 1. That's something we'll talk about. I don't know if we'll use that command a whole lot, but it's something we can talk about. So here we have our basic, simple, and complex behavior. So our first basic behavior, we got motor port 3 equals 63 semicolon. This will turn on a single motor that's plugged into port 3. Of those 10 ports on the Cortex, they're all numbered 1 through 10. So if you have a motor that's plugged into port 3, you would type into your computer motor port 3, and notice that the port 3 is in square brackets equals, and then 63. We'll talk about those numbers. And then finally semicolon. A semicolon is like punctuation. It's like finishing a sentence. Now the next one, the simple behavior. So let's say I have two motors plugged into my computer. One is plugged into port 3 and the other one's plugged into port 2. This simple behavior makes a robot go forward for 2 seconds at half power. So we got both motors, port 2 and port 3. They are both at 63. And then we have this right here, wait 1 capital M SCC, and then 2000 in parentheses. Basically, the computer needs to know how long to leave the motors turned on for. And that's what this code does. So it's telling it to leave on for 2000 milliseconds. That capital M is for milli. So 2000 milliseconds is the same thing as 2 seconds. Next we have our complex behavior. Notice that in the next line here, we got a negative. That negative reverses the direction. So if the motor was turning counterclockwise when it was positive, it'd be turning clockwise when it's negative. And now it's, for 400 milliseconds, or 0.4 seconds. So in this complex behavior, the robot is going to move around the corner. So it's going to move forward, it's going to make a turn, then it's going to move forward again. All right, so let's get some definitions here then. So a basic behavior is the single line of code. And it is the simplest command. So an example would be to turn on the motor. That would be the simplest basic behavior that we can have. Simple behavior is, it's simple yet significant. So think of this as like a useful action. So an example would be, moving the entire robot forward. And then for complex behaviors, think of the big ideas. So, what is the robot supposed to do? Or what is it doing? So, an example for this would be maybe follow a path. So before you ever write a single line of code, you really ought to make some sort of flow chart. Start with your large behavior and work your way to the smaller one. So your complex behavior, then your simple behavior, and then your basic behavior. So maybe you want the robot to move forward, then make a left-hand turn, then make a right-hand turn, then move forward, then to do a 380 or a 180 degree turn, then go backwards. Start with that. and then make a list of everything you need to do that. So, okay, well, if I want it to go forward, I need to turn on the left motor, I need to turn on the right motor, I need to wait 3 seconds, and then finally do a very specific list of actions that you need to do. If you do this, writing your code is going to become significantly easier. So in your engineering notebooks, what I would have you do is, for your autonomous period, start off with, your complex behavior, then break it down into a simple behavior, and then finally break it down into basic behaviors. And then you'd be ready to write your code. All right, this concludes our very first video.